Hey everyone, and welcome. Today, we're going to crack open one of Python's most powerful and honestly most fun built-in toolboxes, the random module. Let's jump right in.
You ever stop and think about what's really happening when you hit the shuffle button on your music app? Or how a video game can pull off a fair dice roll over and over again? Well, the secret sauce behind all of that is randomness, and lucky for us, Python gives us the exact tools to harness it.
But before we can start generating anything random, we got to talk about one of Python's secret weapons, modules. Just think of them as these prepackaged toolkits that save us from having to reinvent the wheel every time we start a new project.
So, what is a module really? At its heart, it's just a file packed with Python code. Functions, classes, all that good stuff. When you import a module, you get to use all of those tools instantly without writing them from scratch. It's seriously the best way to keep your code clean and super efficient.
Now, Python comes loaded with a bunch of these built-in toolboxes, and today we're grabbing the one labeled random. This one is incredibly versatile, as you're about to see.
Okay, here is the first thing you absolutely need to understand. Python's random module isn't, well, truly random. It's what we call pseudo-random. The numbers look random, but they're actually created by a predictable algorithm. The cool part is, we can control the starting point of that algorithm with something called a seed. See on the left? Without a seed, you get different numbers every single time. But look at the right. When you give it a seed, like we did with random.seed42, you get the exact same sequence of random numbers every single run. This is a game changer for testing your code because it makes your results reproducible.
All right, let's get our hands dirty and look at the first set of tools in our module. These are the real workhorses for just generating all sorts of random numbers.
First up, the most basic function of them all, random.randomparen. You don't give it any arguments, and it just hands you back a random float. That's a number with a decimal point, somewhere between 0 and 1. Super simple, super useful.
But what if you need a decimal that's, not between 0 and 1? No problem. That's what random.uniform is for. You give it a starting number and an ending number, and it'll spit out a random float anywhere in that custom range. And, of course, we need whole numbers. For that, we have random.randint. This is your go-to for simulating things like a dice roll. You tell it the lowest and highest number you want, and it gives you a random integer in that range. And importantly, it includes both of those end numbers.
Generating numbers is awesome, but a lot of the time you need to make choices from a list of things. The random module has some really powerful tools for exactly that.
The simplest tool here is random.choice. You just hand it a list, or any sequence really, and it plucks out one single random item. It's perfect for things like picking a random winner from a list of names.
Okay, but what if you need to pick more than one item? This is where you have to pay attention, because there's a huge difference. Random.choices picks with replacement. Think of it like drawing a card from a deck, looking at it, and then putting it back in. You could easily draw the same card again. On the other hand, random.sample picks without replacement. Once an item is picked, it's gone. This is like dealing a hand for poker. Every card you get is unique.
And of course, what's a randomness toolbox without a shuffle button? The random.shuffle function is as straightforward as it gets. You give it a list, and it completely scrambles the order of the items. Just a quick heads up, it modifies the original list directly. We call that shuffling in place.
So we've seen all the individual tools. Now for the fun part. Let's see how we can put them together to build some genuinely useful stuff.
First up, let's do a classic. We're going to use what we've learned to build a super fast prize draw application. Who's going to be the lucky winner? Let's find out.
And I mean, look how simple this is. We just make a list of our participants, Alice, Bob, Charlie. Then we use our new friend, random.choice, to just pick one name out of that hat. That's it. In basically 2 lines of code, we have a fair and random winner. So easy. Let's step it up a notch and think about a password generator. The recipe is actually a perfect mix of what we just learned. First, you make a giant string or list of all the characters you want to allow. Then, you just loop for however long you want the password to be, and in each loop, you use random.choice to grab one character. Finally, you just join all those random characters together into your new password.
We've covered a lot of ground, so let's quickly recap the most important bits. And then, I've got one extremely important warning before we wrap this up.
Here it is, your cheat sheet. If you need a random integer, grab randint. For a float, use uniform. For picking just one thing, choice is your best friend. For picking several unique things, you want sample. To mix up a list, shuffle it. And remember, if you ever need your random results to be the same every time for testing, use seed.
And now for the big one. This is without a doubt the most important thing to remember from this whole explainer. Because the random module is predictable by design, it is absolutely, positively not secure enough for anything related to cryptography or security. Never, ever use it for real passwords or security tokens. For those mission-critical jobs, Python gives us a separate, much safer toolbox called the secrets module. Use that instead.
So there you have it. The whole toolbox is laid out for you. You can simulate, you can choose, you can shuffle. The possibilities are endless. So the only question left is, what unpredictable thing are you going to build first?